Hi, my name is Tyler Walsh. This is my partner Connor Rowland. This is our presentation on abrasive jet cutting versus conventional saw cutting. Abrasive jet cutting was fully established in the 1980s, with the initial idea being created in 1935. It was not fully commercialized until the 80s, that's why I included both. Abrasive jet cutting uses a high velocity stream of water carrying abrasive particles that erode and cut materials through high energy particle impact. This can be used for aerospace materials, plastics, hardened metals, just regular like metal, brittle materials, stacked materials, wood, and rubber. There's two forms of abrasive jet cutting. Regular would be with gas, and then there's abrasive water jet cutting. We're going to explore both later. These are a few examples of abrasive jet cutting and their applications in the field. The top left is just the overall process for abrasive water jet cutting. It shows the abrasive material coming in and mixing with the water to use to cut materials. You got top middle, which is cutting a very thick shaped that abrasive jet cutting can do very easily. You have in the bottom left, you have brittle materials, and on the right is also a brittle material, glass or hard plastic, which saw cutting has a hard time cutting. And then you have in the center, you have stacked materials, which are an advantage that abrasive water jet cutting has. They can cut multiple materials stacked up on each other. And the top right, an example of a rotary mobile abrasive jet cutter that can cut round shapes and intricate molds, not just a flat sheet like regular saw cutting can only do.
Alternatively, there's conventional saw cutting, which is more in the traditional sense, uses serrated edges to cut objects, blanks, or materials. It has a lower tolerance compared to abrasive jet cutting, which is due to it actually having a physical blade. It has various blade types, which can change from circular, band, reciprocating, and a hacksaw. Some advantages of conventional saw cutting is its low initial investment. The parts, the actual machinery is a lot cheaper than abrasive jet cutting. It's also extremely effective in cutting in that it cuts a straight cut very true to its shape is supposed to be. It is a variety of cutting implements, so it can be applied to multiple applications. And it also has high dimensional accuracy, meaning when you're actually cutting, it cuts to the exact shape you want to do. Some disadvantages are its limited cut patterns in that it can only cut a straight line. It can't cut towards a shape or a pattern that a abrasive jet cutter could do. It also exposes the material or the blank to high mechanical forces, which is potentially a problem in a manufacturing setting. It leaves a burr edge, which is also a problem in that it has extra processing that needs to be done. And the biggest drawback is that it also has frequent tool wear, meaning the edge, the machinery all have to be maintenance and treated frequently. Here, I just wanted to highlight some parts of conventional saw cutting in that here's a piece of machinery that uses a circular saw. And in the middle, there's a blade that actually shows each cutting edge of the blade that goes back and forth continually. Here in the third image is a different cutting blade, or cutting implement in general, in that it's a bandsaw and it cuts.
Unique advantages of abrasive jet cutting. Some advantages from abrasive jet cutting are the improved precision. Abrasive jet cutting allows for very tight tolerances and precision cutting of materials. Some precision, like the accuracy, can be up to 0.003 inches and even down to 0.001. There's no heat added in the cutting process, so you can use very soft metals and materials that you don't want a heat affected zone to have. And so abrasive jet cutting is a really good cutting device that you can use to combat the heat affected zones. And the cutting ability of abrasive jet cutting is very good. It can cut through almost any thickness. I've seen examples up to 24 inches where an abrasive jet cutting machine can go 24 inches through a material. And the versatility of being able to cut a lot of materials and different styles of cutting, like the example from earlier slides with the mobile cutting wheel, being able to cut a shape that's not flat is very useful and good for multiple fields. This is a short example of abrasive jet cutting using intricate cutting shapes and how thick the material is from you can see from the video.
Drawbacks of abrasive jet cutting. Some potential drawbacks of abrasive jet cutting is just its high upfront cost and high cost to run. A machine like this, it can cost up to 500,000 and around 200,000 for an average machine. It also uses a lot of energy and resources to run, such as water, its power. It's constantly pressurizing a spray nozzle, which is a very taxing process. Another drawback is its slow cutting process. Since it's basically just chipping away at a material or a blank or some process, it's very slow. It's just individually pulling pieces away from the actual project. A big problem beyond just how it is and how it runs is its potential inaccuracy with the average person. Someone running this machine might not set it up correctly because it's such a high tolerance process. It can lead to it being inaccurate or not cutting exactly how you'd want it to, or cutting smoothly like it should.
Next would be manufacturing readiness level. For the manufacturing readiness level, we would recommend an 8 to a 9. Abrasive jet cutting has been slowly making its way to the forefront of manufacturing. It is a very competitive manufacturing process and is used in a lot of capacities, including aerospace, automotive, and even food. It has a lot of independent programs built just for abrasive jet cutting, so we can change over our processes from a 3D modeling to a abrasive jet cutting format, and the manufacturing documentation is very well out there and available, so it deserves an 8 to a 9 for the manufacturing readiness level. Bias assessment. Our bias assessment of this overall presentation is that we used multiple sources and kept going through all credible sources as we were doing our research, trying to stay subjective throughout all of our finding of information and numbers, trying to make sure that nobody was selling us anything, and just trying to stay as credible as possible.
Our final recommendation would suggest using abrasive jet cutting rather than conventional saw cutting for industrial applications, simply because of its more applicable nature to products. It has a higher dimensional tolerance, which allows it to make more dynamic cuts and shapes and templates. It also has a higher range of materials that you can actually use it on, which makes it more applicable to more jobs in a sense. It also is less taxing on the actual blank or material you're cutting, which can end with a better surface finish, cut region, and no heat affected zone at all. Finally, the biggest application I would say is that there's no tool wear. You can reuse the products over and over, allowing for it to be basically no cost other than just running the product. And here's our citations for the resources we use to get our information.